Hi everyone. Today we're going to talk about the collections framework within Java. We're going to talk about a few different types of collections, and we're going to talk about why you would use one versus another. Today we're going to focus on three main interfaces within the collection framework. First one is list, second one is set, and the third one is map. Depending on the particular use case, you may use a list for something. Let's say you need to do some sorting or you need to know the index of something. If you want to make sure that you guarantee unique values within your collection, you might use a set. Or if you want to associate keys and values together, you might use a map. These three interfaces are the ones you're going to see most often in code, so I want to cover those first. Like usual, let's go ahead and pull up IntelliJ and look at some code. For today's project, let's go ahead and call it collection demo. I'll go ahead and open up our main class. We shouldn't have to generate any additional classes today. We can use the main class, and then we can have some different methods that demonstrate adding elements to a collection and how you iterate over a collection and things like that. So the three things that we want to cover today are list, set, and map. So let's do lists first. So the first thing here is IntelliJ is asking, do I want to import list? And yes, I do. If I hit Alt-Enter, there are two hits. There's from the java.util package and there's the java.awt. So I want to go from the util package because the entire collections framework is within java.util, and that's what we're looking for here. So let's go ahead and just do that first. Now, if I hover over this, get a bit of an interesting message. It says raw use of parameterized class list. So what the heck does that mean? Well, if you look at the documentation a little bit here, it talks about it a little bit. Public interface, so we know what an interface is, and we know what the public keyword is. And we see list like we normally do, and then we see these caret symbols and an E. This is what we call generics within Java. This is our type argument. And what we need to do is we need to define the type argument. I'll go ahead and demonstrate code if you don't have a type argument because that is available and you can code with it, but I highly recommend you do not use raw parameterized types when you have your generics. So what you want to do instead is you want to add these angle brackets and then you define the type that you want your list to contain. So it has to be a reference type. So you could do object, you could do integer, you could do string. I think you get the idea. I'll go ahead and do strings just to make it clear. Now what you can't do is you cannot do a primitive. So let's say I wanted to create a list of bytes. I can't do this. In Java, I have to use the equivalent reference type, which is capital byte. I'll go into, in a different video, the details as far as the differences between primitive and reference type when it comes to these wrapper classes. There are a few little nuances to understand, such as auto boxing and unboxing. I'm not going to go into that too much in this video, but that's a future video I should cover. All right, so now back to list. Let's go ahead and make this a list of strings. And I'm going to go ahead and just give this variable a name of list. Now what we normally do is we assign a value to our type. And in this case, if I were to do this, there are a few things wrong with this. The first thing is if I hover over here, list is abstract, cannot be instantiated. And that's because it's an interface. So what I need to do is I need to assign my list reference here to a class that implements the list interface. There are a few that you would often see in code. The two most often that I would say that you would find would be array list and linked list. If you're not dealing with multi-threading, that is. There are other ones that might be thread safe, and that's a whole nother set of videos. We can go into that. So the most common one you're going to see is array list. So what I just did there is I double clicked and IntelliJ imported array list for me. And one other thing you'll see is that it got rid of the string type in here. And the reason it did that is because in Java, I believe it was Java 7, there was an introduction where you can do what's called type inferencing. So you've got your variable type over here, And now Java can determine, because I know what the variable type is over here, I don't need to define this. I don't need to be redundant. So I can remove that, and that cleans up the code a little bit. Great, so now I have a list. So what do I do with a list? Well, usually the first thing that you're going to do is you're going to determine elements you want to add to your list. Let's add string 1, 2, and 3. All right. So now what I do is I call the add method, and I add in the type that I want to add. And the reason that I'm adding a string is because we define this as a string right here. Let's say I change this over to integer. Now you're going to notice that I'm going to get compiler errors because I'm trying to add types that are not the argument type that I have right here. So I'm going to go ahead and change that back to string, and you'll see that the errors go away. If I were to make this a raw type, then now what I have going on is I have these warnings saying that I have unchecked call to a member of raw type here. And basically what the raw type means is prior to Java 5, when generics were added, collections were still present, but they didn't have the same level of checking that you do get with generics now. So basically what happens after you remove the type reference is now you are dealing with object, and you have less checking you can do. Basically, the only time that you should be dealing with a raw collection where there's no parameterization going on is when you're dealing with code that relies on it. And really you should be asking, why does that code need to rely on it? Maybe you're dealing with some really old code, or maybe you have to integrate a library that's really old or something like that. If that's the case, then maybe it's outside of your control and you can't change it. But if you can change it, I would highly recommend you try to move away from the unsafe type checking that comes with raw collections. It's really much better to use generics. All right, so now we have added elements into our list. Now what do I do with a list? Well, I can pass around a list like I would any other object reference between classes and methods and things like that. And now let's say I want to print out the elements in my list. What I can do is I can use a for loop, and I can iterate over each element in the list. So I can say, I'll go ahead and make this final because I'm not going to change it. List value. And then I'm using the enhanced for loop syntax where I add that little colon there. And what that looks like is I'm saying for every list value within our list, what I want to do is I want to print out list value. Go ahead and run this to demonstrate it. All right, and as expected, we get printouts 1, 2, and 3 for each of our list elements. So basically what's going on here is we pass around this object reference which contains our data structure, and in this case our data structure is a list. Now what if I wanted to order my list, or what if I wanted to get only certain elements out of my list? What I can do is I can say list.get, and then I use an index. So now this looks very similar to what we're used to with arrays, where you would have your array name, and then you have the square brackets, and then the index within there. The list interface is similar, except it uses this get method. So let's say that I want to get the second element. If I print that out, we'll print that. What's this going to print? So this is a good reminder for everyone that Java does zero-based indexing. So list.get0 would get the 0th element of the list, which is going to be 1. And the second element is going to be what we normally think of as the third element, because we start at index 0. And that's going to return string 3. And that's what we get right here. So this works as expected. And then if we watch that we do something that's out of bounds, then we get something pretty similar to what we're used to with arrays. And that is we get an index out of bounds exception. And with arrays, you get an array index out of bounds exception, versus with lists, you get index out of bounds exception. And you'll notice that we are looking at the array list implementation here. And each implementation of the list interface will have custom ways of checking certain things, and they'll have different rules on what a list can and can't do. But generally speaking, if you try to do a get on an element that isn't in your list, you're going to get an index out of bounds exception. That's pretty typical behavior. So you might be thinking to yourself, this sounds an awful lot like an array, and this even says array list right here, so why would I use a list when I have arrays? Well, that's a good question. Let's see what list can offer us. Get, add. Oh, okay, so what's this add? So I can process an index field and then an element. So if I use that, let's say that I want to add at element 1, string 1 again. And now let's say I add my code back for printing out the list. Now what's going to happen? Cool. So what we just demonstrated is when you use the add method on a list, you can insert an element when you already have an existing element there, and essentially what that does is that moves everything down in the list. That's pretty cool. So that's one of the main advantages of lists over arrays, is you have a really simple interface where you can constantly mutate your list, and you can reorder it and all sorts of things like that. You don't have to worry about changing elements around or resizing an array all the time. A list automatically does that sort of thing for you, and it abstracts those sorts of details away from you. Now, if we talk about performance for just a second, if you're worried about how performance gets impacted, let's say that I did this a million times. That's going to get pretty expensive. Versus if I use the linked list, you'll notice that my output's the same, and in fact, a linked list is much more efficient at inserting elements in the middle of a list, whereas array list is really efficient at finding elements within the list once you have already made the list. So while they all use the list interface, depending on your use case, you may want to choose different subclass implementations of your list, and then you can instantiate those when you set your variable right here, and then you can use polymorphism to use the same list interface that you would otherwise, and then callers don't have to know the particular implementation you provided. Some code specifically calls out, rather than the generic list over here, they may call out linked list, or they may call out array list. If you ask me, I think it's better to leave this generic and call it out as list over here. And what that does is it allows better abstraction because everybody's using a common interface. And it's not like for most situations, the specifics on which list implementation you're using make a huge difference in the code that you are using within your application. And if they do, then you can specify a particular subclass implementation if, let's say, you have a performance constraint or something like that. All right, very good. So we talked about adding to a list. We talked about inserting into a list. What if we wanted to remove an element from the list? Let's say we wanted to remove element number 3. And as we can see, element 3 originally was at index 2. Then we added an element to index 1, and that pushed these two indices to later in the list. So now string 3 is at index 3, and we just removed it. So now we get 1, 1 again, and 2. So basically the gist of this is you can use lists to manipulate. You can add, remove, insert, and you can add multiple elements at once. Really, lists are pretty powerful, and they're a good data structure to know how to use within Java. All right, so now I want to spend a little bit of time talking about some of the other methods of the list interface you can use, which are typically used in code. The first one I want to talk about is clear. The clear method is really useful when you need to start fresh with your list. Contains is good for if you need to check if an element is within your list. Then you can use index of or last index of to determine the index of that element. If you want to figure out the size of your list, you can use the size method. And if you want to sort your list, you can use the sort method. Sorting lists and using different sorting implementations is probably its own video in its entirety. The gist of it is that when you sort a list, you basically provide a comparator interface, which is what looks at each element in your list and determines whether it is greater than, less than, or equal. And then once you know the greater than, less than, equal relationship, then the list interface can then use its implementation in order to iterate through all of the elements in your list efficiently and sort them for you. So since we're talking about collections, I just have to mention lambdas and closures for a second here. It's a more complex topic in its entirety, so I'm not going to delve into it here, but I just want to demonstrate an example of a slick way to also print out the elements of a list. And that is using the for each method. And then what I'm going to do is I'm going to use a method reference. So system.out print line. I'm going to go ahead and remove this. And as we see here, we result in the same output. Method references and closures are something that I want to dive into in the future, but I just couldn't resist talking about them briefly in the context of collections because collections use lambdas and closures quite often and are a good opportunity to showcase them. All right, so now that we've talked a good little bit about lists, I'm going to go ahead and move on to set. So just like with lists, if I type set in here, there's only one set, and that's in java.util. And what I'm going to do is I'm going to make a set of integers. This time I'll call it set. And in this case, I'm going to make a hash set. There are a few different implementations for sets you can use, but hash set is the one you're going to see quite often within code. So similar to lists, I can do set.add. And in this case, I'm going to go ahead and do 10. I'm going to copy this code. I'm going to do 9. 8, 7, and so forth. And then similar to lists, I can do set.forEach, system.out, print line. We'll show this working. All right, and as expected, we get the printouts we expect, but one thing you'll notice is that it didn't preserve our order. And the reason for that is because sets don't understand order, and sets can't have duplicate items, where duplicate item is determined by whether two items have an equals method that equals true. So what I mean by that is, let's say that I change this to 10. IntelliJ is already giving me a warning. If I hover over this, it's saying duplicate set element. I'm gonna go ahead and run the code and demonstrate what that means. And as you can see, we're not including element 10 twice. If this were a list, we would be, unless the list implementation happened to be one that rejected duplicates. But 9 times out of 10, you're not going to be dealing with a list implementation that rejects duplicates because you could just use a set. So what are the other cases of why you use a set versus a list? If you don't need to maintain order and you are specifically looking for no duplicates, set often has better performance than list because the internal representation of the set doesn't need to care about any ordering. And all that you need to do is you need to maintain a set of elements, and you don't need to maintain any sort of ordering with it, any sort of relationship amongst elements. All you need to do is verify no duplicates, and that's a relatively inexpensive operation, all things considered. So if you need performance and you don't need some of the other things that list gives you, then you can use a set. And you see sets used in code, but many times people use a list even if a set could be used. Personally, I don't feel super strongly about needing to use a set if you want to use a list anyway. But if you're getting into performance critical code, it's really good to use sets instead. And I can tell you that some people I work with are really big on using the right tool for the job. And the right tool for the job in some cases is set. And I am all for that. But at the same time, there are also people that just say, a list is good enough. So then they just throw in a list, and then other people don't care when they review the code. It kind of depends on the situation. All right, so last but not least, we're going to talk about map. And fun fact is that map is part of the collections framework, but it actually doesn't extend the collection interface. And the reason it doesn't is because map isn't a collection per se, because it doesn't have the ISA relationship with the collection interface, but it is still part of the collections framework because it has a lot of similar concepts to the other collection types we've talked about thus far. So what I'm going to do is I'll go ahead and create a map. And one of the main differences about map is it has two type arguments. It has the type argument for the keys of the map, and then it has the type argument for the values of the map. So I'm going to go ahead and make a map that maps integers to strings. So the kinds of situation where you would use a map is, let's say that you have one value that maps to another. You need to ensure that you have a different key that goes into a certain lock, and you need to get the value out of the lock, but you only have a certain key that works with that lock. That's a case where you would use a map, because when you use a list, there's no inherent mapping there, or a set, there's no mapping there either. Whereas with a map, that's implicitly defined there for you. So I'll demonstrate here with some code. I'm gonna go ahead and make this a new hash map. Kind of like hash set. Hash map is a pretty typical subclass implementation of the respective interface that we're talking about here. So how you add to a map is you do map.put. And let's say that I'm going to have an integer key 4, and now I'm going to map that to string 4. And now I want to do map.put 7, and that maps to string 7. In this case, the mapping is a little bit trivial, but hopefully this gives the idea of how you would add elements into a map. Now, how do you print out a map? Oh, there are a few ways you can. I'll go ahead and show the enhanced for loop version first. For map.entry, and I need to make it integer string. I'll call it entry, and that will be map.entrySet. So that's pretty long. But the gist of what this is saying is, for each entry in the map, I want to create this entry object, and now within here, I'm going to print out entry.getKey and entry.getValue. We'll run this, and I'll demonstrate this working after I comment out the set code. All right, and that's how you print out the contents of a map. So now let's say that I want to access the value with a known key that I have in the map. So let's write some code to do that. My key will have a value of 7. So I don't need this anymore. And I'm still iterating over the entry set. Now what I can do is I can do if entry.getKey equals key. Then I can do found entry.getValue. And there we go. This is an example of how you can use maps to get some information based off of a key. If you don't want to go over the entire entry set, there's another way that you can do it that's possibly a little simpler. So let's go ahead and do that next. For integer keys in map.keySet. So if I hover over keySet here for a second, what this is doing is it's returning a set of the keys, that K type. So now what I can do is I can say, or whoops, I should clean up the variables here. Key to find, and that's the current key. Key dot equals key to find. Then I can do map.get key. And now what this is going to do is it will result in a very similar output. 7. So this code is doing something slightly different. Instead of iterating over the entire entry set, it's only iterating over the set of keys here, so 4 and 7. And then it checks to see if the key to find is the same key that we already have here, and if it is, it then queries the map for the value. If you want to do something that's a little more efficient, it's often more efficient to only look at a map's keys rather than look at the entire entry set of a map. But sometimes it's just easier to already have the map entry available and to look at it there. So it kind of just depends on how you want to access it. And then the last thing I'm going to demonstrate here is I'm going to say value, and you can do map.values. And within here, what you can do is you can print out all the values of the map and ignore the keys. All right, cool. So that iterates over the map and gets all the values out of the map. One thing you might be thinking is, so I have a value, how do I get the key? Well, you can do that, but there's no really easy way to do it. What you'd have to do is essentially iterate over either the whole entry set or over the list of keys and try each key and see if the values equal. Because the problem is when you're dealing with keys in a map, those behave like a set where each key has to be unique, but the values behave like a list where the values can have duplicates. And what happens is if you try to access a key from a value, you could have 3 keys that all point to the same value, and now you don't know which key to talk to. So really the intent of the map interface is to be able to access a value via a key or to access a map entry by iterating over the map as a whole. Hopefully this provided a good overview of how to use map. And that was an introduction on collections within Java. Today we talked about list, set, and map. And in future videos, we can talk more about some of the other things I mentioned, whether it's lambdas and closures, whether it's more on generics, or whether we talk about some of the subclass implementations of these interfaces some more. There are all sorts of topics we could talk about in the future, but I hope this was a good introduction to how collections are used and why you would use certain collections in certain situations. If you liked this video, please do smash that like button. Thank you again for watching this video. I hope you have a good rest of your day, and hope to see you next time. Take care.